Thank you, Rui. Isn't he a great guy? I mean, I really like him. Yeah, in my experience working with professionals in our field, Rui is a special person, and I like him very much. The purpose of this meeting started over 40 years ago with our first user meeting. It was actually about getting people together. It was about you in this case. And it was about getting people together and sharing real experiences. And that's the purpose of this meeting. Normally, I have people stand up, turn around, and meet somebody new. Are you willing to do that right now? You're a little nervous, I know. Why don't you do it? Stand up, turn around, and meet somebody new. Good. Okay, good. Thank you. Thank you very much. Perfect. That's good. Thank you. Thank you very much. Thank you. That's good. Thank you. Perfect. Perfect. Good. Thank you. Stop. Thank you. That's good. I'll repeat myself. The purpose of the meeting is all about you sharing your work, learning from others, learning about the new technology, and growing as a community. This is a very special group of people in Portugal. The work that you are doing is important work. You are designing cities, managing infrastructure. You are looking after the issues, the great challenges of climate change, urbanization and change, vegetation management, conservation, and on and on. At the beginning of this meeting, I would like to share a little bit of your work and also the broader GIS community's work around the world so that you can get a sense of what's going on with this technology. Some of you are looking at issues of environment and climate change. These maps show a range of applications from biodiversity monitoring to looking at air pollution. This map in the center on the bottom is very interesting because it shows the wildfire pollution in Canada reaching all the way across the oceans into Europe. And look at the interesting map of the waste flow monitoring going on by the environmental agency here. These maps are some of my favorite. They show conservation science, but also conservation action, conserving wetlands, restoring forests, and creating new forests in cities, monitoring and setting up conservation zones in the oceans. Increasingly, GIS is being used to manage natural resources, whether they be farms or farming, or forests, or managing mineral extraction. Even in the lower right, we see managing touristic activities and monitoring it to ensure they're protected in natural areas. Our world is changing. We are moving to renewable energy as a resource, leveraging solar and wind. And this company, Finergy, is doing both. generating a new generation of energy to power society. Historically, GIS has been used in cities. It's one of the biggest application areas, managing records like zoning or land use plans. In the lower right, look at the urban design work going on in Vienna, associating urban design patterns with carbon and carbon sequestration. And the videos that you saw earlier show the idea of a digital twin, being able to model buildings inside of cities, evaluating the consequences of a new construction. And speaking about buildings, one of the big trends that's happening is GIS is moving into buildings. It's managing space activities. It's monitoring what's going on in buildings. The Madrid airport or the San Francisco airport are now completely managed using GIS indoor facilities. And the University of Portugal, in the upper left, is using these models to locate and manage solar collection on top of the buildings. For as long as I can remember, GIS has been applied in transportation. And here we see the GIS system in the Swiss railroads keeping the railroads on time. That's supposed to be a joke. Swiss rail networks run on time, as you know. But also managing the railroad networks. And here in Portugal, the road networks, doing drone surveys of the conditions, or real-time monitoring of roads. And in the upper right, we see something amazing, which is the use of GIS to monitor the Navy as well as commercial shipping, all shipping around the region. You know, GIS is being picked up by engineers. They're now using geography as a way to do better design. And they're also using it to deal with underground engineering and above ground engineering. On the lower right, we see the integration of something interesting. BIM models, building information models, merged with GIS and representing visually this dam and the water that's built up behind it. Speaking about water, almost around the world in every organization, GIS is being used to manage water networks, the assets themselves. It's connecting to field data collection so that as people are collecting observational data in the field, it's updating the master database of the network. And in the Northern Water Organization here in Portugal, you can see it's being deployed with a network of water with a new utility network, something that people will talk about during the session this year. Traditional utilities, electric, gas, and so on, have also embraced almost every major region of the world GIS as a framework for doing asset management of distributions and also transmission. These beautiful pictures in the lower left show the vegetation conflicts with transmission lines, or being able to understand everything. Similarly, in telecommunications, the world has changed. We're moving from traditional telecom to broadband and telecommunications of a whole new generation. And geography, seeing who's covered and who's not covered, is becoming a critical issue. These beautiful examples show it. Our cities, our countries are safer because GIS is showing us patterns of crime. It's helping us set up defense security around things like Air Force bases here in Portugal. It's showing us online statistics as they happen. And unfortunately, in Ukraine, it's being used as a command and control system to deal with and assess all kinds of issues going on with the war. Planning and responding to disasters of all types now require modern GIS. The earthquake in Turkey and Syria was overseen by the commanders of NATO. They were able to target emergency rescue, and visualizing and modeling the damage done by the dam sabotage in Ukraine is another example. Some of you are working exactly in this field, looking at wildfires, looking at the possibility of all kinds of disasters occurring. You know, geography is a foundation for statistical data collection. The maps and the administrative areas are shown here in the lower left. And this beautiful portfolio of maps showing change or showing demographic patterns is increasingly useful for government as well as business decision making. In some countries, they've stood up GIS in portals and allow the statistical data to be published for citizen access. In the lower right, we see in Lithuania such a portal. As the census is being collected and updated, the citizens know what's going on. It's like the weather in a whole new way. This linkage between measurement and access is increasingly interesting. Business now, the private sector of all types, is embracing GIS to pick the right location, to get the geographic advantage, to know how to organize dealerships, to understand the impact of risk on insurance companies. This is also just beginning to mature. And the combination of the web and the power of web mapping is quite interesting. It's allowing us to reach citizens with messages like the map here on touristic facilities and activities here in Portugal. It's broadcasting out the news, but it's also connecting citizens in crowdsourcing examples to give back information. This kind of connection is linking citizens to agencies of all types. It's a miracle, really, a kind of new chapter in democracy and sharing, in governing. From the sky, remote sensing, whether it's satellites or imagery or drones, is creating new perspectives. It's enriching GIS in various ways. These examples show it, whether it's in agriculture, showing crop change or vegetation classification, looking at the whole world, precipitation, for example, or micro areas. Imagery is allowing us to pull features out of the picture and update our GISs, and this promises to change everything. Look, all of these examples are stories, and I wanted to share them with you because, as I started out, the power of this meeting is learning what other people are doing. It's not just learning about the technology. Even stronger and more important is learning about what each other is doing, sharing knowledge, learning, and growing as a group of people. The theme of this conference, or the title of this conference this year, is GIS Creating the World That You Want to See. And I suppose all of you have been thinking about what are they trying to communicate? What does this mean? Before we go further, I'll simply say there's 3 words in here that are particularly important: creating, world, and you. So as we start out this conference, I want to ask you the question, what kind of world do you want to see? And take a moment and think of one or two words in response to this phrase. For me, in thinking about this, these words came up, and I suppose they came up in many of your minds. Sustainable, peaceful, in balance with nature, healthy, equitable. These are powerful thoughts, and particularly you in this room can embrace them. Our world, if we start with this, is complex. It's interdependent. We know this as geographers and ecologists. What happens here, like the fires burning in Canada, have an effect on the air quality in Portugal. And it's rapidly today changing and evolving. And increasingly, humans are playing a major part in its future. If we look back 500 years, human species have been growing. They've been highly successful, we would say. They've been creative. They've created cities and agriculture and public health systems and education systems and energy and computing, actually. And as we have been making these innovations, our population has been quite successful. We have, as a species, overcome so many challenges. We've created a kind of civilization. And anthropologists and geologists are now beginning to call this the age of the Anthropocene, where humans are the dominant force on the planet. It's worth contemplating and thinking about what that means. One of the things it means is that our world is now being challenged by the very success of human beings. We are, some people say, overpopulated, and the impacts of our overpopulation on human-induced climate change threaten our future. They create a whole cascade of things that are not good, that we're dealing with at many levels, that the examples of your work showed issues of social conflict or flooding or food shortages or water crises or natural disasters of all type. In my thinking, it seems like we're living beyond our means. Most of you have bank accounts of some sort, and you know what I mean, living beyond your means. Increasingly out of balance, a kind of reckless lifestyle. And what people are beginning to realize is it's not sustainable. You know all of this. This map is a new map of the world. It's a scale from red to green. The red areas are where we are emitting greenhouse gases. The green areas are where we're sucking it back in, sequestering it. And we can see areas, tropical areas, where it's being sequestered. The northern boreal forests, the areas like the Congo in Africa, but we also see the emission areas that are spiking around the world. Some people at this point are simply saying, this is not sustainable. We're living beyond our means. And even some people have suggested humans are not going to be around in the future. It's my opinion that right now we're living at a time of choice, and there's great hope on the creativity of human beings. Sustainability is actually possible, but it's going to take all of our collective work. Rui began to talk about this a few moments ago. We need to imagine and drive our best science and our best technology to come up with solutions. All of these examples are are expressions of that. And we need to move right now, not in 20 years or in 50 years, not a slow evolution, but we need to own it and act now. This concept of sustainability, I would assert to you particularly, starts with geography, seeing the world as one system. This science, the geographic science, is a kind of language that we need to not only embrace, but also promote. This science brings together all the issues, the environmental issues and the social issues and the economic issues into one frame. It organizes all the factors, and it illustrates patterns and relationships, just like some of your maps do. And this approach, this science actually supports an approach, a kind of way of thinking, a kind of way of problem solving. And by the way, this is what many of you do. You support the integration of factors, holistic approaches for problem solving that are visual and understandable, a kind of language to map not only what is, but also what could be. This is very powerful at this particular point in the history of the world. GIS, as a set of technologies, enables this geographic approach. Sometimes we simply gather data. Some of you are data gatherers, remote sensing or field. Others are mappers, others are analysts, others do design work, others make decisions, and others take GIS data and take it to action. This is a cycle of creating understanding, exploring alternatives, and taking action. And from my perspective, you, particularly you in this audience, are interesting because you are engaged in this ecosystem of geographically based activities. Now this tool, this technology, probably the reason why you're in this room, is advancing rapidly, driven by faster computers, driven by new ideas. Here are a few of the big things that are emerging. Distributed GIS, interactive web mapping, 3D, advanced analytics now integrating AI and machine learning, pervasive access through devices or web browsers, storytelling like the dashboards that some of you have, or dashboards like COVID. You know, the COVID dashboard was amazing because it reached almost 40% of the world. People looked at it every day. How many of you looked at the Johns Hopkins COVID map? Yeah. I mean, it was remarkable because it transformed the world's understanding of the pandemic. It wasn't just something in China that I needed to worry about. No, they saw it clearly as a language. And no matter what field you're in, you're beginning to realize that you hold the keys to informing science-based information to the constituents that you serve. This technology is becoming pervasive. Okay, not quite yet, but pervasive within organizations for sure. Field maps and mobile devices are connecting everybody in the field with these institutions. And whether it's in the military, every soldier is a sensor, or in utilities where every field worker is observing and feeding the enterprise, or whether it's in the citizen to local government where citizens are contributing and seeing information in real time, it's the same. And web apps, amazing. These kinds of applications are building on what I will call geospatial infrastructure. What is that? Well, traditionally, GIS has been focused on doing projects, and many of you in this room do project by project. You do an assessment, you find the right solution, and you're done. You move on. Others in this room build systems of record, whether they be cadastral systems or water systems or vegetation systems. You're managing the data in an information system. But a third pattern is now emerging. I like to refer to it as the geospatial infrastructure pattern, where all the individual systems are getting connected with web services, creating a system of systems. And whether it's in the city of New York or the city of Dubai or the city of Beijing, it's the same. Whether it's in the US or whether it's in France or whether it's here, systems are becoming connected with portals. In this case, we see in Australia, the Geosciences Organization in Australia has brought all the national agencies, layers of services together, and it's just changing the whole perspective of the nation. They organized a portal, a WebGIS portal, which defines where the data is, and the content is being brought together dynamically to address particular issues, whether there be climate issues or national security issues or water issues. It's kind of a system of systems GIS. It's just another step. Big organizations are beginning to embrace this, a whole new scale, like the UN with the UN SDGs, the Global Sustainability Goals, pulling data from different departments, different countries. Or the International Geodesign Consortium is looking at making a land use map of the entire world by getting several hundred universities, one of which is here in Portugal, by the way, pulling data, building land use plans that deal with carbon balancing at the planetary level. And here, ICNF in conservation planning is embracing the same kind of architecture, pulling open data together to define a new scale of operations. GIS is contributing to this issue I've been talking about, sustainability. Your work provides the evidence of it. And you, as GIS professionals, are getting better at it. But yet, much more is required. Before I get into the technology part of my talk, I'll simply say that you, as professionals, have an increasingly important role to play in creating a sustainable world. I've said it now 3 times. That is, understanding what's needed and wanted, determining how to come up with holistic solutions, being able to make sustainability a priority in your organization, and then leveraging the latest technology. This is why you're here, presumably. And while doing all of this, it's increasingly important in this crazy world that we live in to maintain the public trust, to not go to the left or go to the right, to go forward with fundamental science. You know, people believe maps, oddly enough. Very few incorrect maps exist. And people believe the messages that you build. So, the end of my first part of this talk, I simply want to assert that creating the world that you want to see requires the exact tools, the exact methods that I've been talking about, and even more importantly, you. Well, the second part of my talk this morning will be our work, that's Esri's work. I have the privilege of working with thousands of software people and scientists who are pushing the envelope at the edge of basic tools. And we do this to help you do your work better. That's what gets us excited. We're not doing it for some ego reason or even interest, although that's also interesting. Our fundamental work is to build great software tools that help you do your work better. And in many ways, that's why these user meetings are useful for me, because people are always complaining, or they're saying, why don't you add this or do that? And that's part of the selfish motivation that I have of being here. So I want to invite you, if there's something wrong in my technology or in our organization, let me know. A lot of our work is built around this product, as you know, ArcGIS. And it's designed to be a comprehensive GIS system, generic, and support many different kinds of communities. ArcGIS is interesting because it can be implemented in different configuration patterns on the desktop or in an enterprise system in this new pattern of geospatial infrastructure with mobile apps and web apps. It's open and it's interoperable. So the components of it work together, but also because it's built on standards, open standards, it can interoperate with all kinds of other IT systems. It's an enterprise system. Well, it's not just an enterprise system, but our aspiration is that it will be an enterprise system just like an ERP or CRM, the big SAP or Salesforce kinds of technologies are enterprise systems. Likewise, GIS is interconnecting inside of organizations the field workers, the knowledge workers, the data scientists, and even the public. Each year, our organization spends about 1/3 of its revenue on R&D. We have several thousand engineers who advance the technology in different areas. These are kind of the portfolio of how we think about it. At the heart of GIS is spatial analytics, and there are literally thousands of tools that do interesting things. You know this better than I. These are some of the new tools in analytics and data science that we introduced last year. And as we move to the web, we're building web services interfaces in browsers to access and manipulate these tools. Tools in AI, tools in modeling, tools in visual expressions, and tools to deal with big data. Here we're talking about billions of observations. One of the research efforts has been integrating AI into GIS. We refer to it as GeoAI. And here it covers applying models to imagery, pulling features out of it. It also applies to applying models and building relationships among and between map layers. And finally, the application of AI to text, to read through a book, georeference the text, and then do the derivative analytics. This GeoAI is one of the two big branches of AI that's emerging. The other is large language models, and this is more experimental now, being able to read through documentation, give us answers, look through very large volumes of data and come up with ways to solve problems. This will also emerge. It's just early days to be a kind of assistant to help us navigate GIS capabilities. What's interesting about ArcGIS is it's a data sharing or a content sharing platform. Through portals and hubs, people are sharing their content with each other, both inside of organizations, like here's my map, I'll let you use it, but also at a global scale. Today, there are tens of millions of maps and data layers and apps that have been shared by our users so that they can help each other. This gets back to this idea of getting to know each other, creating a kind of community. I trust you. I can share with you my content. And that's exponentially growing. Okay, it isn't like Facebook, but it's something like that, where billions and billions of maps are made every day on the web of shared information. I'll let you use my imagery. I'll let you use my geology map. I'll let you use my water map. And I can bring it in and make maps of... In the science field, this is called open science. I'll share my open science with you so that you can build your science on top of my science. And the synergy that comes out of that is remarkable. It's creating a kind of library of content. And part of that is the Living Atlas, where we have spent hundreds and hundreds of millions of dollars gathering together authoritative source information. These are some of the new things that are coming out in this Living Atlas this year. ArcGIS, I mentioned, supports field operations. The design here is to connect all the field workers of an organization right to the enterprise systems. And some of our utility companies have tens of thousands of utility workers. Some of our local governments have thousands of their field people collecting data and also using data. For example, in the New York Police Department, they have 35,000 police officers who are connected. Every crime that happens in the city, they see. They can sort of see around the corner what they're getting into. It's real-time situation awareness. But in the case of electrical utilities, it's interesting because they're in California facing wildfires and doing inspections, doing updates. They can, again, have organization-wide understanding of what's going on. And well, I can go on, but I think many of you in this room know what I'm talking about. New things that have been added here are remarkable. We're making thicker and thicker applications so that we can actually have a little GIS in our pocket, which is connected to information from the organization. Speaking about real time, maps are now real time. Being able to read in real-time IoT or real-time imagery increasingly is giving us the sense of persistent surveillance and persistent information that we can use to more effectively respond. The world is moving to a real-time digital twin. Sometimes I think of this as like your nervous system. Sometimes I think that you are part of building a global nervous system. You know what I'm talking about because you all have a nervous system. You have your eyes, you see things, or you touch things, then you cognate, that's piece number 2, and then you act. This is the way humans do. If we think about this at a planetary level, we're measuring, we're building GIS intelligence, and then we're supporting action, emergency action, or maybe more thoughtful action like planning. It's an extraordinary thing that you are doing, wiring up the nervous system for your organization. Now look, my favorite part is mapping. And many of you are very skilled at mapping. You are cartographers. But the big jump that's occurring is interactive web mapping. That means JavaScript tools that live in a browser that can connect to data and allow me to interactively work with data, massive amounts of data in the web. And this kind of visualization is at the edge of modern cartography. Accompanying this are apps, app builders, instant apps. So I can make a map and put it inside of an app in 30 seconds and then publish it. So maps become almost apps. So the tools that we're working on are templates that make this easy. Well, that's good because a lot of people don't want to know GIS. They want to have simple apps that access these networks of maps. Kids want that in school. This year, we are releasing, in a couple weeks, something called the Map Maker. This is designed with the National Geographic Society to get geographic thinking into kids. And you will see some of them here on the stage in a few minutes. Making maps accessible and easy means making science easy and accessible. And this kind of technology is the beginning. You already are familiar with dashboards, and these are getting better now on devices. I can see my situation anywhere in real time. Finally, I'll conclude by talking about imagery. I started a few minutes ago with imagery. Linking image observation from aircraft, from satellites, and from drones is going to increasingly be something that you get involved in. And ArcGIS has many powerful tools for this, not just for local areas, but for the entire web. I like that idea. It complements something that we're working on in development to build all of our GIS tools in 3D. This means 3D feature layers. It means 3D surfaces. It means 3D meshes, all brought together in the same system. Living digital twins is the way some people are beginning to describe it. This means taking all kinds of content, real-time content, imagery content, vector content, under the ground, above the ground, and have a system of record which is living. You know, digital twins as a set of words came from the automobile industry and aircraft industry, where I'd build a digital twin of a car and I would test it inside of a wind tunnel. That was interesting. I could understand it. But what we're doing in GIS is building living digital twins, which means they're updated transactionally. As we add a building, as we take a new photo, the GIS of the future is a 3D living digital twin. And reality capture is one of the interesting technologies introducing this year, extensions to ArcGIS, which can take traditional aerial imagery and bring it together and process and create 3D pictures. How many of you have seen 3D pictures? A couple of you. Well, let me make it more real. This is Boston. This is a 3D picture. It was processed out of 2D imagery using digital photogrammetric techniques, all automatically created. You can see, some of you know Boston. It's a beautiful city. I went to school there. This is the 3D picture integrated with the subways, a vector layer. And I can also, in my 3D digital twin, zoom right into buildings and see that I integrate in BIM models, the building information models created by architects. These 3D building models can be peeled apart, and I can see rooms inside of them. Isn't this interesting? What's particularly interesting is everybody understands a 3D picture right away. You don't need any training. It's very intuitive. Here we see the skyline of Boston, and the colors are age of buildings based on the vector data behind the 3D picture. And as I zoom again into Boston, I can look underground. I can see the sewer systems or the water systems. It's a 3D living digital twin. This is exciting because it means that I can put in 3D indoor buildings, like in this case, a couple of towers that are in the city. These come from an architect, but I can do looking inside the building. In Hong Kong, in Singapore, these 3D living digital twins exist. I can look at crime that's occurring in my 3D living digital twin and assess different impacts, like, okay, I can touch it. So imagine those same policemen being able to see in their 3D digital. It also allows us to build plans, like these are box models of what it might look like if we redevelop this particular street. This is using urban visualization, 3D zoning pictures. I can use it also to create, with gaming engines, a more living digital twin. So I can talk to citizens about what it would look like during the day or during the night. So GIS living imagery-based 3D digital twins, I think, are in all of our futures for urban GIS. Well, I'll simply say there's lots of development going on. I gave you just a fraction of the work that's going on at Esri. We have teams around each of these different initiatives, and we'll continue to release our tools as we have in the past, also focused on quality and performance in these different capabilities. I'll conclude by saying Esri is now 54 years old. We continue to grow. We're very healthy, and our whole focus is on serving users. It's an interesting company because it's a collaboration of little companies around the world, many of them here in Europe, that are focused, like people like Rui, on supporting you and also advancing this concept of the geographic science and spatial literacy. The philosophy that we often embrace is the idea of working together, and I'd like to have that also be your philosophy of working among and between each other to advance this overall field. Some of the work that we do involves providing free software to disasters, fires, earthquakes, wars, that sort of thing. Also, on our own, we provide our software free to all conservation organizations on the world. We treat them just like normal users, and this has delivered great results for us. Also, we support education heavily, building the next generation. Many of you here are from universities. The higher ed program supports that. But in earlier development, schools program in high school or secondary school, we provide free software, ArcGIS Online, and other tools. We are partnered with the U.S. National Geographic Society to help students learn, and again, we'll see some of that learning going on in a few minutes. Well, that's enough about our technology and about Esri. I'll simply close with reiterating some of the points that I made before. Our world is changing. It's complex, and it's actually threatened by so much of what we do as humans. And I think everybody's increasingly becoming aware of this as we experience together climate change. Our future starts with geographic understanding, and this is a message to you. Recognizing that our world is a single, interconnected and interdependent system in which humans play an increasingly dominant role in its evolution. And I think few people see this as well as you do as GIS professionals, because it's the substance of your work. President Kennedy once said, "We now have the power to abolish global poverty." He spoke these words at his inauguration in 1960. Or also abolish human life. And here he was talking about nuclear holocaust, which at the time was the main existential threat to human beings. And I would assert that today we have that same kind of choice to make, but it's about sustainability and taking responsibility for our future. What kind of world do you want to create? And as players, as very important players in the evolution, in other words, GIS players who are helping do the transactions of change, I'll simply say you have an interesting role to play. Listen, thank you very much. Thank you for inviting me, Rui. Thank you for creating this wonderful organization here in Portugal, and also thank you for being participants in it. And so I'll say thank you very much.